Welcome to qnawire.
For a sample size of n equals 4, the estimated standard error can be calculated as the sample standard deviation over the square root of the sample size. So that's going to be 10, because if s squared is equal to 100, then s is equal to the square root of 100, which is 10. So 10 over the square root of the sample size, which is 4. Square root of 4 is 2. 10 divided by 2 is 5. To determine whether the treatment has a significant effect, we can conduct a t-test, where t is equal to the mean minus the sample mean minus the population mean over the standard error over the square root of the sample size. So this is going to be 75 minus 80 over 5 over the square root of 4, which is negative 5 over 5 over 2, which is negative 2. Using a two-tailed test with alpha equals 0.05 and 2 degrees of freedom, because that's n minus 1, the critical t-value is positive or negative 2.776. And since our calculated t-value is within the critical region, we fail to reject the null hypothesis and conclude that the treatment does not have a significant effect. For part B, for a sample size of 25, the estimated standard error could be calculated as 10 over the square root of 25, which is 5, which is 2. And to determine whether the treatment has a significant effect, we can again conduct the t-test. So we have 75 minus 80 over 2 over the square root of 25. And so that would be negative 5 over 2 over 5, which is negative 12.5. Using a two-tailed test with an alpha of 0.05 and 24 degrees of freedom, the critical t-value is positive or negative 2.064. And since our calculated t-value is outside of this region, we can reject the null hypothesis and conclude that the treatment has a significant effect. So increasing the sample size decreases the standard error. As the standard error is inversely proportional to the square root of the sample size. And as the standard error decreases, the t-value increases. Making it more likely to reject the null hypothesis. And therefore detecting a significant effect. In general, larger sample sizes are more likely to detect small but meaningful effects, and they provide more precise estimates of population parameters.